So go back to your purple page in your notebooks. It is on page 12, and this is the page where we were learning to first solve inequalities. So these are just basic inequalities, and you should have everything filled in except for the interval notation. And so I'm just going to kind of briefly and quickly write in what we had for the solutions. So we had for the solution for this first example, we had that x is less than 11. For this example, you had for the solution x is less than or equal to -1. Oh, sorry, +1. And then the last one, we had all real solutions. Okay, so, and then we had the graph, and the graph is really simple to understand. So we had 11, and then 0, and then -11, and then our graph looked like this. We had an open circle at 11, and our arrow went to the left-hand side. That's what you should already have in your notes. Okay, so let's write the interval notation for this. So again, remember with interval notation, we want to begin and go from left to right. So if I start on the left, the first thing I come to is an arrow, and that arrow is pointing to the left, which means it is -infinity. And then if I keep going, the graph stops at 11. So there's my 2 points. Now I just have to determine if they are brackets or parentheses. So infinity is always using parentheses, and then the open circle, so if you need to go back and look, you can look back. An open circle is also listed with parentheses. So I'm going to put parentheses on both sides, and inside I'm going to have the coordinates -infinity, 11. And that's it. That's the interval notation for this inequality. Okay? So this one we had 0, 1, and -1. And so the graph had a closed circle this time because it says or equal to, but it still went over this way to the left. Okay, so again, interval notation requires that we order them from left to right. So the first thing I come to on the left is the -infinity again. I stopped at, I think I covered up my 1. I stopped at 1, but this time the 1 is in a closed circle. So this time I'm going to put a bracket, and the bracket just means that it includes the 1 as the solution. So one side has parentheses, one side has brackets. And then remember the last solution we found ended up being all real solutions. And so remember we drew a number line, but then on the number line we drew, we drew one big long arrow to show that every single thing on the number line would be a solution to this inequality. Okay, and so for the, if everything solves this, then it's going to go from -infinity all the way to +infinity, and those will be inside parentheses. There won't be a number because it never stops. It goes in both directions forever. Okay, so that's the page that gave us the solving inequalities, okay? Now, the next page that we did was the ones that included the and the or, the compound inequalities. So I'll go through those and then we can kind of see the solution. So on this first example on the and side, we came up with the following solutions. X is greater than 6 and x is less than 9. And so our graph looks something like this. We had -1, 0, and then we had 6, and we had 9. Okay? And the way the graph looked is we had 2 open circles, one on 6 and one on 9, and then they met. Okay? So since this is a compound inequality, but it's an and inequality, the interval notation is still going to be one set of points. And they're open circles, so I can automatically determine that those open circles are going to be parentheses, not brackets. And then it begins at 6 and it ends at 9. So the interval notation looks simply like just a normal XY coordinate. Okay? All right. Number 2, the solutions were x is greater than or equal to -1, and x is less than 3. And so our graph looks something like this. We had a 3, a 0, and a negative 1. And, oh, I probably should do that above. I don't have enough room right there. Let me write it smaller. 3, 0, negative 1. Okay. And our graph looks like this. So we had an open circle on the 3, but we had a closed circle on the 1, and then they met in the middle. So again, we have one set of points because it's an and. It has a definite beginning and a definite end. And so it begins at negative 1 and it ends at 3. But negative 1 is a closed circle, so that one's going to be a bracket, and the 3 is going to be a parentheses because it's open. Okay? All right, and then number 3, our two solutions were x is greater than negative 1 and x is less than 8. Okay? And so we had our graph. Sorry, I guess that one was not drawn in. And we had a negative 1, a 0, and an 8. And let me do this. Just kind of scoot that. Whoops. Hold on. I didn't want to recognize all of it. There we go. Okay. And so then I'm going to put an open circle at negative 1 and an open circle at 8, and then they meet. So again, the interval notation is going to be both parentheses because they're open circles. And so it's going to be negative 1, 8. And it's going to look very similar to simply having a coordinate, okay? And then we learned on this last one that it was supposed to be an and, but our solutions ended up being d is less than negative 8 and d is greater than 5, and when you graph those, they ended up being an or. They went in opposite directions. So we wrote that there was no solution, and the reason we said that is because we wanted the solutions that make both of them true. That's what the and means. So we're not going to be able to do the interval notation for this, okay? So we're just going to say no solution. We can't write the interval notation if there's no solution, okay? And then we had 3 or examples, and this is where we're going to need to use 2 sets of things for the interval notation. So this one, the first example, we had that x was less than 4 or x was greater than 5, and so they're really close on the number line. Like we had, we had negative 1, 0, and then we had 4 and 5. And then when we drew in the graphs, they looked like this. There was an open circle on 4, but the values that are less went to the left. And then there was an open circle on 5, and the values went to the right, okay? And so we have to name both sets of points, okay? And we're going to connect them with that U, which means or, okay? So if you look from left to right, the first graph, the first thing I see is a negative infinity. So I'm going to put parentheses, negative infinity, comma. It ends at 4, and 4 is an open circle, so I'm going to close it in parentheses. Then I'm going to put the U, and then I'm going to keep going to the next graph. The next graph begins at 5, and it's an open circle, so it will be parentheses. And it keeps going to the right, and at the very end is an arrow, and that means positive infinity. And remember that infinity symbols always use parentheses. So it's actually this whole thing that is your solution or your answer, because it includes everything, okay? All right, and then on number 2, we had x is less than negative 4, or x is greater than negative 2. And so on the number line, we had a negative 2, a negative 4. Oops. I need to write those smaller. Hang on. So, negative 4. And then I think we just had like 0 and 2, something like that. Okay. So we had an open circle on both of these. Okay. But this is to the left was our arrow. And this one was to our right. So if I put them in order from left to right, I'm going to come to the negative infinity first. So again, I'm going to put parentheses for negative infinity. And it ended at -4. Then I'm going to put the u. And then the second graph began at -2 and went in the positive infinity direction. So there's my graph for this one, okay? And then the last example, remember what happened on the last example. It's supposed to be an or, but because the answers were this, it actually made one arrow go to the left and one go to the right, but it basically covered the entire number line. And so what we did was we just kind of drew one big arrow again to represent all real numbers, because that was the solution for this one, was all real numbers. So even though it's an or, and I'm supposed to write 2 sets of coordinates, I'm going to do kind of what I did before. I'm just going to put all the way from negative infinity, whoops, that's a bad infinity symbol, negative infinity to positive infinity, and that's it. And remember, that uses parentheses. Okay? All right, so on the last video, we'll do just a few more, and we'll do the ones that are for absolute value inequalities.